So this is Ryan Bismachin, and he will be giving an intro to functional programming.
Thank you. As Lyle said, my name is Ryan. I'm a software engineer at PayPal. I work on the wallet, so we just React, Redux, Node, TypeScript, all that good stuff. And something that we've been really taking to heart is using functional programming to just make our code more readable and scalable, because at PayPal, just tons and tons of data, tons and tons of dealing with hundreds of countries, it can be hell. And we've really been able to, basically everything that I do in this presentation, it's going to be super basic, but it's all stuff that we're using in our code base today. And I'm sure there's some of you that know more about functional programming than me, so if I do anything incorrect, let me know. But this stuff should be pretty intro, and I'm sure you guys have used some of this in your code overall. So going to start off, pure functions, like basic building block, currying, partial application. Probably talk about some point free in that process. Function composition specifically, because composition itself can be a whole topic that I'm probably not going to be qualified to talk to you about the whole time. And some basic functor stuff that maybe you know, maybe you don't, but you've probably used it. So what is functional programming, right? So it's just a programming paradigm modeled on mathematical functions. So you just, if you look at something like Haskell, it'd be like an abstraction on lambda calculus. If you remember ninth grade math, maybe, it's f of g of x stuff. And functional programming buys us this style that we call declarative. So it's more like a description of what we're doing, whereas imperative would be kind of like the process and how we're doing it. Think I'm going to map over an array versus I'm going to write a for loop and I'm going to describe every step of it. So if you're writing React and Redux, I'm sure you know all that. So let's just dive into it. So pure function is a function that, given the same inputs, will always return the same output, and it has no side effects. Common misconception, though, is that in functional programming, people say we avoid side effects, and that's just not true. We have ways of handling side effects. If you don't have side effects, your app's probably not doing all that much. You have to be able to interact with networks or display something to the screen and do whatever you need to do. So don't think we don't have side effects, we just have ways of handling them and generally kind of isolate them and whatnot. So all my examples, by the way, are going to be really, really simple because I'm a simple person and because I'm not going to try and put up some crazy stuff and have everybody try to grok it out. So yeah, as you can see, we just have a basic add function, takes an a and a b, returns a plus b, right? If I give it 1 and 2, no matter how many times, it's always going to be 3. It's not going to change. Array.slice, it's a straight up method. It's not going to mutate the original. You're going to get a new copy of an array, not going to mutate anything. If you look at the bottom part, we're clearly mutating the variable a. So if we called it with 1, we're going to get 2 different results, not pure. Splice, I never really use splice. Maybe some of you guys do, but that's a mutative array method, and that's just going to change the original. So stuff that we generally don't do when we're keeping things functional and pure, and that's because you kind of lose track of you can lose track of what's going on in different states. And if you're familiar with Redux, probably have written one of these before, and basically, and it's often talked about in Redux that we have a way of kind of predicting what our code's going to do. We're able to say, given this state and this action, we're going to get out this, new state. And that's just a product of keeping things pure and composing, actions and everything. So, yeah, it's just small building blocks, and it all builds onto the, more crazy FP stuff. So just in case you don't know what a side effect may or may not be, just think of a mutation like I showed you. Input output stuff, disk write, network requests. If you want to think about well, why can't that be impure? Let's say we're making a network request in a function and the network goes out, we're going to get a 404, or we're going to get whatever we get, versus if we had a regular network request and it got our data back, maybe we're getting that data back. So it's just changing, an outside state, something that, we can't necessarily control. Like I said, not forbidden to use side effects. We just have ways of handling them. So currying is probably one of my favorite things that I probably use all the time. And if you use Ramda Lodash or one of many utility libraries, you probably use it too. So you think of just regular currying as a function that takes one argument and returns a function expecting an argument until it returns a result. So you can curry 3, 4, 5 times. Eventually you're going to return a result. So Ramda Lodash uses auto currying, which is a mixture of currying and partial application. And I'm sure if you've used it, you probably have a better idea of it, but you'll see in a minute, I guess, as I have a small Ramda example. So here, again, we just took that simple add function and we curried it. So we have an A returning a B, which returns A plus B. Then we have to call it with these guys. And we can partially apply, which I'll talk about next, one, and create a new function called increment. So if we want, we can just use, inc now and give us 2, because inc's basically waiting for its B. So yeah, partial application, it's applying fewer arguments to the function than it expects, right? So we're giving it partially what it wants, right? Not the whole deal. And if you've seen personally, I use Ramda. I just think it's a really good, well-written library, but basically it auto-curries stuff. So if we look at a function like this, probably everybody's at some point written something like it. We're taking a function, it's expecting this string, we're going to return split on that string. And instead, we don't really need to pass around this point, right? We have this str, and we already have a function coming from split. So if we just give split the string, it's going to return to us a function expecting, what we want to split on. So pass a hello world, and you split it. So function composition, like I was talking about before or earlier, I mentioned f of g of x. Sure, if you've gone through some math at some point, you've probably seen it. I know I did, and I was like, why would I ever use that? And then I started doing functional programming. So basically, you can think of function composition as applying a function to the output of another function. X and G get done, and then you pass it to F, so to speak. And so there's basically some basic law, which is associativity, and that's, if you remember, like math. So basically, it doesn't matter how we group these, as long as we maintain the order, we can group them how we want, and the result will be the same. And so this dot is just my poor way of doing the actual composition circle, which I didn't want to look up the keys for because I'm lazy. But it's that little circle that does whatever means composition. So composition is associative. That's all we care about right now. By the way, I had to reorganize these slides and make them bigger so you guys could hopefully see them. So that's why stuff like this will be off center. So I apologize. But yeah, so you could just see compose. So compose is from right to left, just kind of like function composition is itself. And we can see if we give it identity and then pass it over inc twice, compose that and compose it, blah, 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 blah. They're equal to each other. Give everybody a quick second to digest it if you can't, but that's just proving the law that we just spoke about here. So back to my stupid little examples. We'll take our curried add function, call it inc, and I just put this here to show that this is in itself function composition. You don't need to use compose or pipe, or I think Lodash has a flow right and flow left. You don't need to use, this is function composition, right? We're composing functions. We're taking the output of calling add and passing it to increment and then incrementing it. But we could also write out a little nifty compose method right here. So compose, as we know, f of g of x, so g and x get done first, so we're going to talk from right to left. So basically, ES6, grab all the arguments, which would be all the functions we're taking in an array, return a function that expects a starting value, calling it x. We're going to reduce from the right. If you don't know, that method does exist. So instead of reduce, just do it from the right side, and it does the same thing. And we have the accumulator, which will be essentially our starting value, and we have the function. We're going to apply that function to the accumulator. It's going to become the accumulator, and we go on from there. So if you use it, you can see if we pass in 2 to add 1, so 3 plus increment 4, we have compose. You could also just, sometimes I'll do this depending on what I'm doing, or maybe I'm going to reuse a composition, different types of methods, or maybe different action or different reduce. So you can store your composes from later. I personally prefer using compose just because like it's mathematically correct. Some people prefer pipe, which is just from left to right. So instead of reduce right here, you just use reduce. But that's just personal preference. So I hope I'm doing okay on time, but I'm on functors now, and I hope that that's okay. So simple, like if I was to be like, somebody was like, in the simplest terms, what's a functor? I would probably say it's just something that has a map method, right? It's an object that we can map over. Really straightforward, simple terms, but if you wanted like a better answer, I'd say it has to obey the laws of identity and associativity. And by the way, when I say map over, I don't mean like an iterable map. I just mean applying a function in a context. So that's what array.map does, but it also iterates. So we have an array, and we're going to map the identity, and I know this is like JavaScript land, so like triple equals might be a little bit different, but we're just going to say straight, like looking at it, array of 2 is going to be equal to array of 2 here. I know like object equality and stuff is going to be all whack. And then associativity, I made these 2 helper functions, f and g. We're going to take array.2, we're going to map g, map f. Everybody's done that before. It's the same thing as doing composing it and grouping it first and then composing it that way. Similarly with a promise, .then is essentially a map. It's just called .then for whatever reason. And same basic concept. So if we wanted to see, like I was saying, everybody's probably used functors before, right? We've all probably mapped over an array. Maybe you're using ReactJS streams, or maybe you're using promises, or one of many different ways of using stuff. So it just kind of goes to show you that the stuff that I'm talking about isn't really new. It's stuff that maybe you already knew about. If you didn't know about, you're already using it probably. You just probably maybe didn't know the functional part of the FP terminology. So we're just going to build a basic functor from here, my code. So this is called like the identity functor, not all that cool, but basically we have a called ID, a variable called ID, or it's a function, takes a value, right, and we're returning an object. That object has a map method. What does that map method do? It applies a function, wraps it back up into an ID, and we have a fun little box that we can now call .map on. And there's the laws, as I was just talking about. So the identity law is there. Associativity is the same. And I mean, it's probably not something that you're gonna like go write in your code base tomorrow, but it kind of gives you like a starting point of like how things are working. And in case it's not clear, I did use ES6 stuff, but in order to return the object straight away, you have to kind of wrap it in the parentheses, otherwise it's gonna think it's a concise arrow body. So that's why the parentheses are there. So that's really all I got. I don't know how much time I took or if anybody understood anything, but I can try and answer questions if you have any. So thank you.
So like in Redux, reducers are a lot of people's like first exposure
Yeah.
to like pure functions.
Right.
Can you talk about like some of the steps that you do at PayPal scale to mitigate, to make that easy? Because the examples are like object.assign, state, and doing a bunch of
To make it
stuff, and
easy?
people are like, well, I use, yeah, like how do you typically like manage these pure functions and at scale like that?
Well, I guess like the nice thing about the pure functions is like, well, how do we manage it? It's just not perfectly is my first part, because there's like way too much going on, and we have like many combined reducer calls because we're creating like nested reducers. I think kind of the beauty of using pure functions though is by default it's generally relatively simple. One thing that we've started doing is what I was trying to show today was composing pure functions. So we keep them as small units of composition, right? Maybe we have like a function that gets the user's credit card data, and then we have a function that might map over that data and do something to it, and then we'll have something that like checks if they're like a certain member of some experiment we're doing. So as long as we keep those things really small, in the unit composition. And like also something I probably should have mentioned is like functional programming super testable. So we can keep, you know, we can do TDD when possible, and we can keep all that stuff simple so that when we do like a compose, it's pretty straightforward where to see in the pipe thing might go wrong. So I think the one thing is we're trying to keep things small, and that's my long-winded answer.
You use like any immutability helpers?
We, before I got here to PayPal, they tried immutable.js, but because big company and time constraints, they were just like, we can't do this right now. We installed Ramda about 2.5, 3 months ago, and it's been really awesome. We started using it for lenses, and then we were like, we're not really using lenses all that well right now, but we love everything else it's giving us. So that's not like immutable data structures, but it preserves immutability for us, or it doesn't mutate.
How do you isolate side effects like network requests?
So I'm not super qualified to speak about all of that, but probably a Haskell person would probably say like there's different types of monads that you do. Like I know some basic Haskell, so there's like the IO monad for like input output, and like I said, it's not something that I can like really dive into and explain to you, but it's definitely something that, or that's a way. I think you could also isolate it with like a task. So there's different, like, there's actually a really cool GitHub repo for JavaScript called Fantasyland. And it's a functional programming specification for algebraic data types. So I could probably pull it up, because why not? Yeah, I'm Batman, by the way, if you didn't know. What am I looking for? Fantasyland, this guy. So it's like, because everybody's going to argue about like what this takes and what that takes and math. This is just like, here is a specification for us to follow. And you can see like functor is just like one part of many. And like monad is down here. And there's like some really confusing, but not really that confusing saying that like a monad is just a monoid in the category of endofunctors. And that's in there. But yeah, so I think that this is a cool place to like check out different FP stuff. If you like, I mean, granted, you're gonna probably want to learn like Hindley-Milner type signatures and stuff and try to understand some of that. But that's my answer.
I have a 6-part question about monads, actually.
Oh, great.
No, this is really good. Thank you.
Thank you.
I just read a really shitty book on Haskell, and this was way better.
Oh, well, oh boy.
So, where would you send people for further resources to actually like practice some of this stuff in JavaScript?
So, several parts to that. I think the best resource for at least JavaScript and stuff is Professor Frisbee's book. If you've read that, you're probably like, that's it. It's a really good book. He has a video series, but it's like a really weird talking puppet hedgehog thing, and the voice is really weird. The content's really good, but some people can't sit through it. That being said, it's really good. He also, the guy's name is Brian Lonsdorf. He has some really good talks on YouTube that I totally watched to make sure I didn't do some stuff wrong. And that's another good place to talk. I also learned a ton of stuff from Eric Elliott. So he has a lot of good Medium articles there. Highly opinionated, but you know. So that's where I would direct people personally, and that's what I've been using. Cool. Thanks, guys. What's up?
Thunks or sagas?
Thunks or sagas? Sagas. Yeah. I don't know. I think delaying the evaluation of a function to like return it is sagas, but like sagas are overkill most of the time. Observables, that's where it's at.
So before we wrap up, I want to give a plug to Kyle Simpson and his Functional Light
for sure.
JS course. He has a book, and it's free on GitHub. And he's also on a lecture on github.com and front-end masters. And great, it's a longer introduction. It's like 6 hours long to functional programming. So Functional Light JS by Kyle Simpson.
Yeah, Totally.
There's also a really awesome podcast called the Lambda Cast.
Oh, really? I haven't heard that one.
Yeah.
Is that good?
Yeah. It's
Oh, dope.
Really good.
Cool.
They cover topics sort of sequentially, and they'll dedicate like an entire episode to like
Oh, for sure.
functors, and then
Oh, hell yeah. That's probably cool.
So
Probably way better than me.
Data types.
yeah.